some functions are called even and some functions are called odd and some are neither. So when is a function even or odd? And does this have anything to do with even and odd numbers? That is what you will learn in this video. We call a function f of x even if f of x equals f at minus x, if both x and minus x are in the domain. And we will call a function odd if f at minus x equals minus f of x, or f of x equals minus f of minus x. So how does that look in a picture? So suppose we have for positive x a function which looks like this. So what happens if you are even? If x and minus x are in the domain, here we have x and here we have minus x, then f of x and f of minus x have to be the same, so these values over here. And this has to be true for all x's, so take another one, get here. So you already see how the figure has to look. It looks something like this. So a function is even if it's mirror symmetric in the y-axis. So it looks like a parabola basically. What about odd functions? So suppose we have some function for positive x, which again looks like this. Then we need at minus x to have f at minus x equals minus f of x. So we again pick some x. Here we have our f of x, here we have our minus x, and our minus f of x will be somewhere over there. Do the same for another point, a bit closer here, and then we get over here. And then you see we also have to mirror but also flip, and our function becomes to look a bit like this, like an x cubed. And those are also examples. So what are examples of even and odd functions? Well, the function 1 is an even function, the function x squared. Like if you flip in the y-axis, it remains the same. Odd functions are, for example, the function f of x equals x, like you flip through the origin, or x cubed. Those are examples of odd functions. And functions which are neither, many functions like e to the power x and 1 plus x are neither even nor odd. Now we have a fourth example. So if you have a number of even functions, if you flip all x's, you flip all the functions. So if you take linear combinations, you keep an even function. And if you have an odd function and take a linear combination of some odd functions, you still have an odd function. Now what about products? There we have to be a bit careful. So if f1 and f2 are even and g1 and g2 are odd functions, if you take the product of two even functions, what do we get then? So we look at f1 at minus x times f2 at minus x. Both are even, so for both we have f1 of x and f2 of x. So at minus x, f1, f2 equals f1, f2 of x. So the product of two even functions is again an even function. What happens if we take the product of two odd functions? So we evaluate g1 times g2 at minus x. Both are odd, so g1 at minus x equals minus g1 at x. And g2 at minus x equals minus g2 of x. But those two minus signs cancel out. So we get at minus x and x at g1 times g2 is the same. So a product of two odd functions is again even. Now what happens if you do even times odd? So even function f1 times an odd function g2. f1 at minus x equals f1 at x, so nothing happens. And g2 at minus x equals minus g2 at x. So we get minus times f1 times g2. So we pick up a sign. So a product of an even and odd function is an odd function. So we have to be a bit careful, not exactly the same as the numbers. So what does it have to do with the numbers? Well, even functions are functions like x squared, x to the power 4, x to the power 6, x to the power 8. So even functions have an even number and exponents, and odd functions are functions like x, x cubed, x to the power 5, x to the power 7 have an odd number in the exponent. So that is linked to the even and odd numbers.